Using chain rule. So to do differentiation using chain rule, for example, y equal 3x plus 4 to the fourth power. To do this differentiation using chain rule, when you differentiate y, you get dy by dx. And so in order to use chain rule, what you do is you carry down the power 4, you subtract 1 from the power, 3x plus 4, and then we subtract 1 from the power, so this is now 4 minus 1, and then you multiply by the derivative inside the bracket. The derivative inside this bracket is 3. So using chain rule, this is working out to be 4 times, this is going to be 4 times 3x plus 4 raised to the third power times 3. Now instead of putting times 3 again, and then I'm just going to multiply it on the inside right here, because we know that 4 times 3 is 12. So that would be the derivative of y equal 3x plus 4 to the fourth power. That's dy by dx. This is known as chain rule. Easy, soft. All right, we're looking at how to differentiate trig functions. To differentiate trig functions, when you differentiate sine, you get cosine. So this is what we do. You're going to get dy by dx is equal to, when you differentiate sine, you get cosine of whatever is given. So you're just going to get cosine of 2x minus 3. But the key is that you multiply by the derivative of what's inside this bracket. And the derivative inside that bracket is 2. And so dy dx works out to be 2 times the cosine of 2x minus 3, 2x minus 3. That's dy by dx. Nice and easy, soft. That's dy by dx. Nice. All right. Now y is equal to tan cube of 4x. If y is equal to tan cube of 4x, then that means that dy by dx is equal to, first thing is we want to adjust this, and you're going to rewrite this as tan cube of 4x really means tan 4x all being cubed. That's what this means, tan 4x all being cubed. Now to differentiate this, you carry down the power 3, then you subtract 1 from the power. So now you get tan 4x being squared, but then you're going to have to multiply by the derivative inside the bracket. When you differentiate tan 4x, what would you get? You would get sec 4x. You would get sec square 4x. But then you're going to have to ask yourself, what's the derivative of 4x? You then multiply it by 4. So it's a lot of multiplying by. That would be the derivative of tan cube 4x. So finally, the derivative works out to be 3 times 4 is 12. So that's going to be 12. And this is how they write it. They write it as 12 tan square 4x sec square 4x. Sec square 4x. And that's the derivative of tan. Easy, soft. All right, now here's a cost function. To differentiate a cost function is not bad. To differentiate costs, when you differentiate costs, you get minus sign. So what you're going to get is dy by dx is equal to differentiating the cost of any function of x. To differentiate costs, you get minus sign, negative sign of what is inside the bracket. And what is inside the bracket? 2x squared plus 3. 2x squared plus 3. But then you have to multiply it by the derivative of what's in that bracket. And the derivative of what's in that bracket is 4x. So multiply it by 4x. So dy by dx is working out to be minus 4x times the sine of 2x squared plus 3. So it's minus 4x times the sine of 2x squared plus 3. Nice and easy, soft. That's how we differentiate costs. All right. Now, sometimes we're given the product of two functions to differentiate. And in order to do that, we use what is known as product rule. So to do this differentiation, we use product rule. So to use product rule doing differentiation, this is what I always like to tell myself. If y is equal to u, if y is equal to u times v, then that means dy by dx or y prime is going to be equal to v du plus u dv. So after lots of practice, we get used to this. So pretty much you're calling u to be your 2. So this is your u is your, call this your u is 2x to the 5th minus 1 squared, that's your u. Then all you need to do is write down what's your du. Your du would be, using chain rule, carry down the power 2. So it would be 2 times, in bracket, 2x squared, 2x to the 5th, sorry, minus 1. Then you subtract 1 from the power to become 1. And you multiply it by the derivative of what's in the bracket, which is 5 times 2x to the 5th differentiated is, I believe that is 10x to the 4. So finally what you get for du is 10x to the 4 times 2 is 20x to the 4. This is 20x to the 4 times, in bracket, 2x to the 5th minus 1. 2x to the 5th minus 1. Nice. So that would be du. No issues at all. But then this is your v. It's like you have a v now. Let's do v in a different color. V is equal to, that is tan cube of 4x. Tan cube 4x. And how do you differentiate v? Then dv would be equal to, carry down the power 3, subtract 1 from the power, so that becomes tan square 4x multiplied by the derivative of tan, which is, when you differentiate tan, you get sec square, so we get sec square 4x, but then we multiply it by the derivative of 4x, which is 4. So dv works out to be 3 times 4 is 12. So dv works out to be 12 times tan square 4x sec square 4x. Sec square 4x. Nice and easy and soft. The only thing now that we have to do now is put them together. Because remember, this is y, but we want dy by dx. So what we're going to do now is write that dy by dx is equal to, remember, it is v du plus u dv. So it's going to be v, this is v times du. So to multiply these two together, it doesn't matter which order you write it as. So v times du is going to be 20x to the 4 into 2x to the 5th power minus 1. That's du times v now, which is tan cube 4x. This is tan cube 4x. That's what we have, tan cube 4x. That is dy by dx plus u dv. Where is u? See u there? This is u. So plus u, which is 2x to the 5th minus 1 squared multiplied by dv, which is being multiplied by, so dv right here, all of this, which is 12. This is 12 times tan square, 12 times tan square 4x, sec square 4x. Nice and easy, soft. Now, of course, in an exam, you're always going to have to pretty up this answer. So I can't bother write out dy by dx. I'm going to write y prime. So y prime would be equal to, many times what they do, they look for what's in common between the two of them. We notice there's a 2x to the 5th and a tan square in common. So what they do is they'd factor out 2x squared, they'd factor out 2x to the 5th minus 1 times, they'd factor out tan square 4x, factor out tan square 4x, and so what you'd be left back with is what's inside the bracket, and what's inside the bracket is, this is 20x to the 4 times tan. So I'm left back with, in this bracket, factor out 2x to the 5th from this and factor out a tan square from this. So I'm left back with 20x to the 4 times tan 4x, and then when I factor out 2x to the 5th from this side, I'm left back with 2x to the 5th minus 1 times, from this side I'm left back with plus 12 sec square 4x. And let me see if I can manage to fit it in right here, plus I really want to make some space. This is 2x to the 5th minus 1, and this is being multiplied by 12. Oh boy, how can I fit it now? 12 sec square 4x. So right here should be 12 sec square 4x. All right, let me see if I can squinch it a little bit better. Plus, this is 2x to the 5th minus 1. This is 5, and this is being multiplied. It's being multiplied by 12 sec square 4x. 12 sec square, 12 sec square 4x. Nice. And then we can close up the bracket on the outside. And that's it when you factorize it. You can, of course, simplify inside this bracket if you may, but that doesn't matter. But this is a typical question that you'd have to use product rule.